calculation X, right? So this force over here, right? So this force over here, this is shear. The shear is going in our Z direction. And the intersecting plane is Y. So this is our shear Y, Z, okay? The intersecting shear force, there is a setting plane is a Y, there's a setting plane is a Z, the shear force is Y, correct, okay? So this over here is our shear stress, and we calculate the vertical surface. And the vertical surface over here is related to our shear flow in this direction, as you can see now. So again, the same, the shear flow is controlled by the major web. And then you have things coming in this way and this way. So again, we so-called have our terminus. Okay, so this is how we relate our shear force resistance to our shear stress, okay, of the fastener. So in this context, right, in this context, what I'm trying to highlight to you is that is why the shear flow Q, right, is related to what? This shear flow over here. Okay, this can be your Q or it can be your tau. Okay, so that's how it's related. Now, the fastener resistance force is determined experimentally. Okay, so you measure how much force to put the nail. So I don't know how many of you have built a deck before, right? You build a deck, you need to put nails like this. Okay, this can be nails, by the way. Okay, it can be nails. So the force required to prop the nail is dependent on the length of the nail, and it's also depend on the diameter of the what? Of the nail. Yes or no? So the longer the nail you buy, the higher is the resistance force, or the bigger the diameter, the higher the resistance force. But you have to take note, the longer the nail, the more time you need to nail into the wood. Okay, so you have to be careful. So this formula that I'm going to teach you, or that we're going to learn, right, will help you determine what sort of spacing in between two nails. Okay, what sort of spacing that we need to put. Okay, and I've done a lot of consulting on this regarding, like, there are some not me but clients of a certain company want to put a grand piano, for example, on a deck. Okay, what sort of nail, or put a not a piano, sorry, a outdoor kitchen, a heavy outdoor kitchen, how much fastener we need to have. This is the sort of calculation we have to use. Okay, there are two rules. Okay, two rules that we have to know when doing this analysis, and these are the most critical, because if you don't get it, you don't understand this concept, then formulating this calculation is going to be difficult. So we're going to put in two extra rules. Okay, so for longitudinal shear, okay, the analysis must include two extra rules. Okay, the first one, the first rule that we have to have is the member, okay, must entirely distribute the shear flow or shear stress. And the second rule is the joint or fastener is used to transmit the shear stress or the shear flow or shear stress from one member to another. Okay. So these two rules, and I will explain how does this work. Okay, because as I said, it's not straightforward. Okay, it's not straightforward. Okay, how does this work? Okay. So if we have a look on this structure now, same structure, and we will have this in stages. Okay. Oops. Okay. So now let's visualize this. Okay, let's visualize. So now we have
What was the second rule? I didn't catch that.
say it again.
What was
Oh,
the second rule? I didn't catch what.
Okay, the joint or fastener is used to transmit the shear flow or the shear stress from one member or to the other.
Okay, thank you.
Okay. So these two rules are very you have to obey them. Then I mean, in order to do this analysis, you have to visualize this first. If you can't visualize this, that's where problem will come. Okay. Right. So now let's look at stage one. Okay. So I'm going to call this as our member number one. And then this is our fastener. And then this is our member number two. And this is our member number three. Okay. So now we have our shear force coming down. Okay. And I'm going to call this our stage one. So stage one, the shear flow must distribute in the member first. Okay. So the shear flow must distribute in the member. Okay. So this is our Q. And the shear flow, right? This is our Q, right? And our shear flow will distribute across the entire member. Okay, across the entire member. So Q will distribute across the entire member. Okay, so it's this whole thing. Okay. After it distribute, then it will transmit. Okay, so stage one is the distribution. Okay, then stage two is the transmission transmit via the fastener to other members. Okay, you have to apply these rules strictly. So what do I mean? So stage 1 is done already. So stage 2 is then the transmission of the stresses or the shear flow via the what? Transmission of the shear flow or shear stress by the fastener. Okay, right? So again, stage one is what? It has to the distribution has to be on the entire member. Stage 2 is the transmission of the shear flow by the what? By the fastener. And this has to be in this order. Okay. If not, the analysis is very complex to comprehend. Okay. So as I said, let's rather than just me yapping, let's look at an example. Okay. I think I'm a strong believer by doing an example, you can clear your doubt. Okay. So be patient with me. Like my daughter will say, patient. Okay. So be patient with me. Let's look at the example. Okay. It's a learning example more important in your understanding than anything else. So let's look at example number 3. Okay. And this example is let's look at the example. It's okay. No point talking without the question. Okay, so again, we're going to use this entire structure over here. And see what values are given to us. Okay. Okay. Again, this is not a straightforward example. Okay. If you were to ask me, I say this is a real engineering problem. Okay. So a double web griddle. Double web means you have web number 1, as you can see over here, web number 1, and you have web number 2. It's constructed from 2 plywood sheets that are secure to wood member at the top and the bottom. So this is known as our wood member top. This is our wood member bottom, right? And given to us, it's interesting, this problem. The allowable bending stress for the wood is 8 KSI. So they have given us values that, hey, this is shearing stress. Why you give us normal stress? Okay. So the stress, normal stress allowable is equal to 8 times 10 to the power 3 PSI. Okay, given to us. And if you look at this, they deliberately highlight bending stress. So we have been through bending stress before, right? So we know that this stress is equal to mz over izz multiplied by y. Okay. So it's as you can see with the formula, it is a symmetrical bending, right? Because the bending moment is only about one axis. Okay. Then given to us the allowable shear stress, the shear stress allowable is equal to 3 times 10 to the power 3 psi. Okay. And then the allowable shear stress formula we know is equal to Vy over Izz Qz divided by T. Okay. That is the formula. Now these are the formula that we're going to use. And the last part given to us is the uh, fastener or the spacing between fastener is what? 6 inches. And we know that this is equal to S. And the resistance force for given to us, okay, read this, okay, is 600 pounds for single shear. Okay, so resistance force for single shear is 600 pounds. Okay, so all these are all given to us. Okay, I repeat again, all this information are given to us. So when they give us these three values, okay, it's for a reason. Okay, it's basically due to the modes of failure. Okay, because at the end of the day, we are going to calculate the value of P. What is the value of P and what controls the value of P? Okay, so what are the possible failure modes given or we have to analyze? So by looking at the formula, right, by looking at the formula, so the first thing we have to do is failure or mode 1 failure. Okay, due to fastener.